You're floating, adrift in an ocean of impossible scale. There are no landmarks here, no up or down. Only the cold, silent light of stars, some of which have been dead for 1,000,000 years, and the humbling, soul-crushing emptiness in between. In this place, the loudest thing in the universe is the sound of the blood pumping in your own ears. Every grand, violent event, every exploding star, every colliding galaxy unfolds in a profound, eternal quiet. This isn't just an absence of noise. It's a presence, a fundamental quality of the cosmos that's as real and as powerful as gravity itself. We are creatures of a noisy planet, conditioned to expect a roar with every spectacle. But space doesn't play by our rules. The universe, a different kind of symphony, one played not in sound but in light, time, and scale. For us to truly appreciate it, we must first learn to listen to its silence. Tonight, we're embarking on a two-part journey. First, we'll surrender to this cosmic quiet, drifting through the serene and terrifying beauty of interstellar space. We'll feel its stillness and meditate on its scale. Then we'll return to the world of physics to understand why this silence is one of the most fundamental and inescapable truths of our universe. We'll explore how sound works, why space breaks that system, and how, in a strange twist, scientists have still found a way to hear the unhearable whispers of the cosmos. This isn't just a journey into the void. It's a journey into the very nature of perception, reality, and the beautiful, lonely silence that holds everything together. So, dim the lights, put on your headphones, and let the noise of the world fall away. It's time to feel the silence. Let go of your anchor. Imagine the jug of Earth's gravity fading, the blue marble shrinking behind you until it's just another point of light in a others. You're pushing past solar system beyond the last whispers of the solar wind, crossing a boundary that is both invisible and absolute. You are now in interstellar space, the space between the stars. Look around you. There's no spectacle of fire, no dramatic rush of movement. There is only a deep, abiding stillness. From here in the vacuum, the stars don't twinkle. The lack of an atmosphere to disturb their light gives them a sharp, unwavering intensity. They're like diamonds scattered on black velvet, their brilliance both beautiful and indifferent. Some are the soft, warm yellow of suns like our own. Others burn with the fierce blue-white fire of young giants, or the dull crimson glow of ancient red dwarfs nearing the end of their long lives. But they aren't just points of light, are they? They're destinations, each one separated from you by a gulf of time and space, so vast it defies human comprehension. To travel to the nearest one, Proxima Centauri, would take our fastest current spacecraft tens of thousands of years. The light you see from some of the most distant stars in our own galaxy might have begun its journey when dinosaurs roamed the Earth. You aren't just looking at space, you're looking at deep time. Now turn your attention away from the stars and into the blackness that separates them. This is the interstellar medium. It's not a perfect emptiness. It's a vast, incredibly thin soup of gas and dust, mostly hydrogen and helium atoms, the primordial building blocks of the universe left over from the Big Bang. But it is incredibly sparse. On average, you might find only a few atoms in a cubic meter. To put that in perspective, the air you breathe has about 30 quintillion molecules in the same amount of space. Yet, over the unimaginable distances between stars, this sparse material adds up. It gathers into colossal, ethereal clouds called nebulae. Imagine drifting towards one. From a distance, it looks like a faint, colorful smudge against the black. But as you get closer, it resolves into a breathtaking celestial landscape. It's a cosmic nurse when you start seeing a bath of gas when years high, born pillars of radiation and stellar winds from by the intense radiation. Stellar winds from the young, hot stars blazing within. Hues of pink and red from glowing hydrogen gas mix with the brilliant blue of reflected starlight and the dark, intricate lanes of cosmic dust. It is a place of serene, silent creation. There's no sound of the stellar winds, no roar of nuclear fusion igniting in the hearts of newborn suns. The entire magnificent process unfolds in a silence so complete it feels sacred. These clouds of gas and dust are incredibly cold, just a few degrees above absolute zero. And yet, within them, gravity is patiently, relentlessly at work. Over millions of years, it pulls these sparse atoms together, slowly building them into denser and denser clumps. As the pressure and temperature at the core of these clumps rise, a star is born. The moment of ignition, a flash of fusion that will burn for billions of years, happens without a sound. It is a silent genesis. Now let your journey take you beyond the into the open ocean of interstellar space. You feel a sense of profound space. You feel a sense of profound isolation, but also a strange sense of connection. The iron in your blood, the calcium in your bones, the carbon in your DNA, every heavy element that makes up your body and your world was forged in the heart of a star that lived and died long ago. That star in its final moments exploded in a supernova, scattering these newly created elements across the galaxy. Those elements then became part of a new nebula which in time formed our sun, our planet, and eventually, you are in the most literal sense made of stardust. You're a child of the cosmos, a thinking, feeling part of the universe looking back at itself. And in this silence, in this vast, lonely expanse, you are home. The silence here isn't empty, it's filled, it's the canvas upon which the universe paints its grandest masterpieces. It is the quiet womb from which all stars and all worlds are born. This is the peace that passes all understanding, the deep, resonant, quiet sound and will outlast it. Galaxy, Hill the scale. The Milky Way galaxy, your home, contains over 100 billion stars. And our galaxy is just one of an estimated 2 trillion galaxies in the observable universe. Each sprawling, silent island of stars, separated from its neighbors by millions of light years of even intergalactic space. As you float here, in the quiet darkness, you are a single point of consciousness in an ocean of unimaginable size. Perspective be terrifying. It can make you feel impossibly small and insignificant. But it can also be liberating. The worries and stresses of your daily life, the conflicts and anxieties of a small world, all seem to fade into irrelevance against this cosmic backdrop. The silence cleanses the mind. It allows for introspection, for connection with your own thoughts and feelings without the constant chatter of the outside world. Scientific studies show that silence can reduce stress and lower blood pressure. It is a form of healing. Here, in the ultimate quiet room, your mind is free to roam, to wonder, to dream, to simply be asterisk. There is no future past, no future. There is only this eternal, silent present. A moment of pure existence suspended between the stars. The visual journey continues. You drift past strange and beautiful phenomena. A pulsar, the hyperdense, spinning remnant of a massive star, sweeps a beam of radiation across the cosmos like a celestial lighthouse. You see the light, but you hear no pulse. You pass near a binary star system, 2 suns locked in a graceful, silent-gravitational dance. Their colors and sizes are stark contrast against the black. You see a rogue planet, cast out from its home star system, doomed to wander the cold darkness alone for eternity. Its surface is frozen solid, its ice-sphere thin ice sheet. It is a ghost world moving through silence. And then you see a galaxy. Not just stars of our own Milky Way, but an entirely different galaxy flying on Andromeda, our nearest large neighbor. It appears as a faint, elongated oval of light. You know, it's a city of 1 trillion stars, a spiral of unimaginable beauty and scale, 2.5 million light years away. Every event within it, the birth of stars, the death of stars, the collision of worlds is happening right now, and has been for millions of years completely unheard. This is the great, silent ballet of the cosmos. A performance on a stage of infinite size with a cast of trillions playing out over billions of years. And you have a front row seat. You're a witness to the universe in its most raw and honest state. A universe not of sound and fury, but of light, gravity, and a deep, profound silence. Take a final moment to absorb this feeling. The feeling of weightlessness, the feeling of infinite space, the feeling of absolute quiet. This is the true sound of interstellar space. It's the sound of nothing, which is the sound of everything. Let it wash over you. Let it fill you. Let it become a part of you. This is the meditative heart of the universe. And now let's return to the world of noise and atoms and physics to understand exactly why this silence isn't a feeling, but a fundamental law of reality. The experience of that profound cosmic quiet isn't just a poetic or meditative concept. It's a hard reality dictated by the fundamental laws of physics. The iconic tagline from the 1979 film Alien put it perfectly: in space, no one can hear you scream. This isn't just a clever line for a movie poster. It's a concise and accurate lesson in acoustics. But to understand why space is silent, we first need to understand what sound actually is. On Earth, sound is a mechanical wave. That means it needs a medium, a substance made of particles, to travel. Think of it like a chain reaction. When you speak, your vocal cords vibrate. These vibrations push against the air molecules, press, causing molecules then push against the molecules next to them, and so on, creating a wave of compression and rarefaction, a pressure wave that travels through the air. When this wave travels use your ear, it causes your ear to vibrate, and your ear. This vibration. The takeaway here is the key need for molecules to bump into each other. Sound can travel through air, a gas, water, a liquid, or even a steel bar, a solid. In fact, sound travels much faster and more efficiently through denser materials because the molecules are packed more tightly together, allowing the vibrations to pass from one to the next more easily. An elephant can communicate over long distances by stamping its feet, sending low-frequency vibrations through the ground. Whales communicate across vast stretches of ocean because water is an excellent medium for sound. But what happens when there is no medium? What happens when there are no or very few particles to carry the vibration? This is the situation in interstellar space. As we journeyed through it, we learned that space isn't a perfect, absolute void. It's a perfect vacuum filled with the interstellar medium, a very thin soup of gas and dust. But the key word is thin. The density of matter is extraordinarily low, though it varies wildly. While dense molecular clouds can be millions of times denser than the emptiest regions, the average is still a vacuum more perfect than anything we can create in a lab. Imagine trying to start a domino rally where the dominoes are placed a kilometer apart. You can topple the first one with all the force you can muster, but it will simply fall over in isolation. The chain reaction never starts. The wave never propagates. This is precisely what happens to sound in space. Let's imagine a hypothetical catastrophic explosion to the event's force. The collision itself would certainly create a massive vibration at the point of impact. But the vibrations have nowhere to go. The handful of atoms nearby would be pushed, but they are so far apart that they wouldn't meaningfully bump into their neighbors. The pressure wave would dissipate almost instantly. The chain reaction is broken before it can even begin. You could be floating a mere 100 meters away from this colossal event, and you would see the brilliant flash of light. You might feel the heat if you were close enough, but you would hear absolutely nothing. This is the fundamental difference between sound waves and light waves. Sound is a mechanical wave requiring a medium. Light, on the other hand, is an electromagnetic wave. It does not need any particles or any medium to travel. It's a self-propagating ripple in the electromagnetic field, carrying its own energy. This is why we can see the light from distant stars and galaxies. That light has traveled across millions or even billions of light years of near-empty space to reach our telescopes, while any sound from those same objects died at its source. So, when science fiction films depict exploring starship engines in the vacuum of space, they are taking artistic license for dramatic effect. A real space battle would be a beautiful, terrifying, and completely silent ballet of light and destruction. However, the story of sound in space has a fascinating and often misunderstood twist. The rule that sound cannot travel in a vacuum is almost absolute, but not entirely. Highly specific lab experiments have shown that sound waves can tunnel across a vacuum gap, but only under very particular conditions and over incredibly small distances, smaller than the wavelength of the sound itself. This involves special crystals that convert vibrations into electric fields and back again, allowing a sound to leap a microscopic gap. While a fascinating discovery, it doesn't change the reality for our ears in the vastness of space. The more significant exception involves things that are like sound, but aren't sound in the way we experience it. Space isn't entirely empty. It's filled with plasma, a fourth state of matter where atoms have been stripped of their electrons, creating a sea of charged particles. This plasma is extremely tenuous, far too sparse to carry conventional sound waves. But because the particles are electrically charged, they can be influenced by magnetic fields and can generate their own waves, plasma waves. These are not sound waves. They are oscillations in the plasma, ripples of density and pressure within the ionized gas, much like waves on the surface of an ocean. And this is where our story takes a turn, thanks to two of humanity's most distant emissaries, the Voyager spacecraft. Before we dive into the ghostly sounds captured by Voyager and what they truly represent, if you're enjoying this journey into the science and wonder of the cosmos, please take a moment to subscribe and click the bell icon. We explore the biggest questions in the universe, from the silence of space to the mysteries of black holes and the possibility of alien life. And let me know in the comments, what does the silence of space make you feel? Or loneliness, peace? I'd love you to read your thoughts. In August 2012, after a 35-year journey, NASA Voyager 1 spacecraft made a monumental crossing. It passed through the heliopause, the turbulent, fuzzy boundary where our sun's magnetic influence gives way to the interstellar medium. It became the first human-made object to do so. For years, scientists had been waiting for this moment, and the confirmation came from a very unexpected source, a form of listening. Voyager 1 is equipped with a plasma wave system, an instrument designed not to hear sound, but to measure the density of the plasma environment it travels through. It does this by detecting the vibrations or oscillations of electrons in the plasma. Think of it like a boat on the ocean. Even on a calm day, the boat bobs up and down, and by measuring the frequency of that bobbing, you can learn about the properties of the water waves. For years, as Voyager traveled through the bubble of plasma of our sun, its instrument detected low-frequency plasma waves. But in late 2012 and again in 2013, after massive solar flares from our sun sent shockwaves rippling out, something changed. When these shockwaves hit the interstellar plasma surrounding Voyager 1, they caused it to ring like a bell, creating intense plasma wave oscillations. The Voyager team detected these new oscillations. The pitch was significantly higher than what they had measured before. This higher frequency was the smoking gun. It told them that Voyager was in a much denser plasma environment, the interstellar medium. Across the firmament here is where the magic understandings. Plasma waves occur at frequencies that fall within the range of human hearing. Even though they aren't sound waves, scientists can take the data from Voyager's instrument and simply play it through a loudspeaker. The electrical signal from the instrument is translated directly into a sound we can hear. This process, and sonification. What does this actually mean? It means NASA did not record the sound of space. What you're hearing is a representation of data. It's an audio graph. The pitch of the eerie whistle corresponds to the density of the plasma. The volume might be mapped to the intensity of the wave. It's no different in principle from taking a data set of temperatures and representing it as a colorful map. We're using one sense hearing to interpret data that was collected in a form we can't directly perceive plasma oscillations. This technique of sonification is becoming an increasingly powerful tool in astronomy. Scientists can translate all sorts of data into sound. The brightness of a star in an image might be mapped to pitch, and its color to a different instrument. A scan across an image of a galaxy might produce a wave of sound that rises and falls with the concentration of stars. This not only creates a new and often hauntingly beautiful way for the public to experience cosmic data, but it also has real scientific benefits. For one, it makes astronomy more accessible to the blind and visually impaired community, who can now listen to the structure of a nebula or the distribution of galaxies. And the human ear is exceptionally good at picking out patterns, especially patterns in time. A subtle, repeating signal that might be missed in a noisy graph could become immediately apparent as a rhythmic pulse in a sonar dataset. The sound of two black holes merging, which made headlines a few years ago, is another prime example. Gravitational waves are ripples in the fabric of space-time itself, not sound waves. But when detectors like LIGO register these ripples, the resulting signal, a chirp that rises in frequency as the black holes spiral together, can be converted directly into an audible sound wave. Hearing that chirp is a direct audio translation of the vibration of space-time, so while interstellar space remains acoustically silent to the human ear, it is far from quiescent. It's humming with information. It's filled with the whispers of plasma, the echoes of cataclysmic events in the form of gravitational waves, and the steady stream of light from countless stars. We just need the right instruments and the right techniques to translate that silent symphony into a form we can understand. The silence we feel is real. The inability for sound to travel is a hard physical limit. But the universe speaks in many languages, and sonification is simply us learning to translate one of them. It's a way of using technology to extend our senses, to hear the ghost in the machine, and to connect with the cosmos on a new and deeper level. This brings us to our final point: how this scientific reality of silence has been used as a powerful tool of storytelling. The profound silence of space, a fundamental physical reality, presents a unique challenge and a powerful opportunity for filmmakers. For decades, science fiction largely ignored it. Starships roared past the camera, lasers pew-pewed, and explosions boomed, all in service of a familiar cinematic language. It was exciting, but it was a fantasy. Then, films like Stanley Kubrick's 2001: A Space Odyssey began to explore a more authentic approach. But it was perhaps Christopher Nolan's 2014 masterpiece, Interstellar, that most deliberately and effectively used the contrast between sound and silence to immerse the audience in the reality of space travel. Nolan and his sound team made a conscious decision to respect the physics. Scenes that take place in the vacuum of space are often experienced in a deafening, uncomfortable quiet. This isn't just a gimmick, it's a core storytelling device that works on multiple levels. First, it creates a visceral sense of realism and immersion. When the ship Endurance glides past Saturn, we see the majestic rings and the tiny spacecraft, but we hear only Hans Zimmer's haunting organ score, or the sounds from inside the cockpit, the hum of life support, the clicks of switches, the astronauts breathing. The moment the camera perspective shifts outside the ship, all sound originates. This abroad vanishes, instantly grounds them, making them feel as if they are right there in the void. This technique is most powerful during moments of intense action. Consider the now famous docking sequence, where Cooper must manually dock a spinning ship. The scene is incredibly tense, but all the exterior shots of the violently rotating spacecraft are completely silent. We only hear the frantic dialogue inside, the straining of the controls, and Zimmer's thundering score. The contrast between the chaotic visuals and the external silence is deeply unsettling. It amplifies the feeling of isolation and the immense stakes of their situation. Perhaps the most brilliant use of silence in the film is during the explosion of Dr. Mann's sabotaged airlock. We see the catastrophic explosion in stark detail, a blinding flash of light, debris flying everywhere, but it unfolds in absolute, bone-chilling silence. Our brains are wired to expect a massive boom. The absence of that sound is jarring and counterintuitive. It creates a moment of shock that's far more impactful. It emphasizes the cold, unforgiving nature of space. Physics doesn't care about your drama. The universe doesn't provide a soundtrack for your destruction. The silence makes the explosion feel more real, and therefore more terrifying. Nolan's use of sound, or the lack thereof, is intentionally impressionistic. The emotional state of a character, the scale of an event, the feeling of these can be communicated through the layered use of picture, music, and the strategic absence of sound. In the case of Interstellar, the silence isn't just an absence of noise, it becomes a character in itself. It is the antagonist. It's the vast, indifferent wilderness that the characters must survive. This approach taps into a deep psychological truth. Quiet solitude can be both calming and unsettling. It forces introspection. In the quiet of space, the characters of Interstellar, left alone with their thoughts, their fears, and their hopes. The silence magnifies their humanity. The film's central theme, the connection between a father and daughter across time and space, in a gulf that is separated all the more poignant by the immense, silent gulf that separates them. By embracing the scientific reality of silence, filmmakers like Nolan are able to craft a more profound and emotionally resonant experience. They aren't just showing us space, they're making us feel it. They're using the physics of the universe as a tool for art. The silence in Interstellar is the perfect marriage of the two halves of our journey tonight: the meditative, emotional experience of the void and the cold, hard science that explains it. It reminds us that sometimes the most powerful thing you can hear is nothing at all. We began our journey adrift in a silent sea of stars, surrendering to the meditative calm of the cosmic ocean. We felt the awe, the isolation, and the profound peace of a universe without sound. Then, we returned to Earth, to the realm of physics, and understood that this feeling is rooted in a simple, elegant truth: sound needs a medium, and the vast expanse of interstellar space is a near-perfect vacuum. Vibrations have nowhere to go. The cosmic order, but our journey didn't play through. But our journey didn't end there. We discovered that while the universe is silent to our ears, it is not quiet. It's alive with information, humming with plasma waves and shuddering with the gravitational echoes of cosmic collisions. We learned how the ingenuity of science through sonification allows us to translate this inaudible data into a form we can perceive, giving us a new way to listen to the whispers of the cosmos. We're not hearing space itself, but a translation of its language. Finally, we saw how this fundamental silence, far from being a limitation, has become a powerful artistic tool. What is the silence of interstellar space? A meditative state. Bring a sense of peace and perspective to our noisy lives. It's a physical law, a consequence of the nature of waves and the sparse, tenuous fabric of the universe. It's a scientific frontier, a realm of hidden data that we are just beginning to learn how to hear. And it's an artistic choice, a source of profound emotional power in our attempts to tell stories about our place in the universe. The silence of space isn't an emptiness, it is a presence. It is the foundational bass note of the cosmic symphony. It's the stillness from which all motion arises and the quiet canvas on which all light is painted. To feel it is to connect with the universe in its most fundamental state. The next time you look up at the night sky, past the noise of our world, listen. Listen not for a sound, but for the vast, beautiful, and eloquent silence that binds us all. It's the sound of everything and the sound of home.